Now for the first part, x minus iy. I calculate first x minus iy. Therefore, x minus iy will be equal to a cube minus 3ab square minus I into this. You note the other thing, ib. That means there is no real part. That means the simplified value of this fraction or expression will be imaginary. Good morning. Welcome to btosacademy. Welcome to my maths class. Today, actually, continuation class of complex numbers. Already I have written few sums. I shall work out one by one first. Given x plus iy is equal to a minus ib. Cube root of x plus iy is equal to a minus ib. Then we have to prove these two. First this, then this. Since there is cube root, first I cube both sides. Cubing x plus iy, that will be equal to a minus ib whole cube. Now we expand a cube minus 3 into a square into ib plus 3 into a into ib whole square minus ib whole cube. We calculate by using I square equal to minus 1. It will be a cube. I take this will be real. I square b square means minus b square minus 3ab square. Since these two will be real, we take together plus I into minus 3a square b I cube b cube means minus I b cube. Since I cube is equal to I square into I and the value of I square equal to minus 1, therefore finally it will be this. Then I have taken I common factor. There is another minus, therefore finally it will be this one. Therefore x plus iy is equal to a cube minus 3ab square plus I into b cube minus 3a square b. Now already we have learned the property that if two complex numbers be equal, then their real parts will be equal and imaginary parts will be equal. We will write here comparing or equating real and imaginary parts x is equal to a cube minus 3ab square, y is equal to b cube minus 3a square. Now for the first part, x minus iy. I calculate first x minus iy. Therefore x minus iy will be equal to a cube minus 3ab square minus I into this Now we can arrange, keeping in mind the expansion of a minus b whole cube or a plus b whole cube, then a cube three a b squared, that can be written as I square b square minus, if I take minus b square, then I can write that as I square b square. This one plus 3 a square into ib, then ib cube is there, therefore this will be ib whole cube. You mention here, since I square equal to minus 1. Therefore we get the form a cube plus 3 plus 3 a square b form plus 3 ab square form. We could have written this term first, then we get this form a plus ib whole cube. Therefore x minus iy is equal to a plus ib whole cube. Therefore cube root of x minus iy is equal to a plus ib. That is the first part, a root. The first part is this. For the second part, we have to use these two values. We have to prove x by a minus y by b is equal to that. I mentioned here, part B. We have x equal to a cube minus 3ab square. As we have to find x by a, I take a common factor. Therefore, x by a is equal to a square minus 3b square, and y is equal to b cube minus 3a square b. B is the common factor, b square minus 3a square. Therefore, y by b is equal to b square minus 3a square. Therefore, x by a minus y by b is equal to a square minus 3b square minus b square plus 3a square. A square plus 3a square, 4a square minus 3b square minus b square, that is equal to 4a square. I take 4 common factor. Note, x equal to this expression, we see a is the common factor. I have taken a common factor. from that x by a. Similarly, we have got y by b. Then we have subtracted y by b from this, and after simplification, result is this. Therefore, the part is proved. Given z minus I by z plus 1 is equal to IB. First of all, z is equal to x plus y. We put the value of z and arrange the left hand side. Therefore, x plus iy minus I divided by x plus iy plus 1, that is equal to I. Also, students, learners, you note the other thing, IB. That means there is no real part. That means the simplified value of this fraction or expression will be imaginary. Keep this in mind. Or x plus I y minus 1 written in the standard form. Also the denominator x plus 1 plus iy. It is mentioned that x, y are real numbers, that is equal to IB. Now we have to multiply the numerator and denominator by the complex conjugate of the denominator first. Or x plus I y minus 1, complex conjugate of this one is x plus 1 minus iy divided by a plus ib. When it is multiplied by a minus ib, then the result will be now we simplify the numerator. If we write the whole, that will be larger. That is why I do like this. First I simplify the numerator. X into x plus 1 minus I square y into y minus 1. I have multiplied so that the real parts come first, plus I x plus 1 into y minus 1, then minus xy. I suggest students you follow this trick. Write the product so that you get the real parts first. X into x plus 1. Both are reals, therefore product will be real. Then imaginary into imaginary. That will be minus I square into I as y into y minus 1. This one, there is I square, therefore that is minus 1. Therefore, we have written keeping that in mind. Then imaginary part I into these two, then these two. Just to simplify and get x square plus x plus y square. I square means minus 1, therefore it will be plus minus y plus I. Keep it intact. Already I have mentioned that right side is IB, means there is no real part. Therefore, after this step, from 1, real part of LHS is equal to 0. Very interesting thing. You note, real part of left hand side will be 0. From that we get x square plus x plus y square minus y is equal to 0. You note, we have to prove this. From that, since x minus half whole square, x minus half whole square, real part is equal to 0. From that we get this one. Now we have to make perfect square. Student, you note that earlier I wrote x minus half whole square, but after getting this step I find that should be x plus half whole square. X square plus 2 into x into half plus x square plus x, that is to be written in the perfect square form. Therefore, this plus y square minus 2 into y into half plus half whole square is equal to half whole square, half whole square. These two terms have been taken in extra. Therefore, for adjustment we have to write 2 into 1/4, that is half, or x plus half whole square plus y minus half whole square is equal to half. Therefore, we get that relation. The other thing is that sometimes the question is asked like this: if this, find the locus of the point Z on the complex plane. For that version, we have to work out up to this. This part will be same. After that, I mention here extra. The above equation is the equation of a circle. When the circle topic will be discussed, you will see that general form of circle, also called center radius form, is x minus alpha whole square plus y minus beta whole square equal to r square. Here we find that for x minus alpha whole square plus y minus beta whole square equal to r square. From that we make the comment that this is a circle. Its center is half minus half half, and radius equal to r square equal to half. Therefore r will be equal to 1 by root 2 unit. Since z lies on the complex plane, therefore center, this is coordinates form, therefore complex form will be minus half plus I into half, and radius is 1 by root 2 unit. X plus IY form, note that, and radius is 1 by root 2 unit. Students are suggested to note this part. This was not actually in this problem, but I have discussed separately this one. It will be required later.